Every second, somewhere inside a glowing industrial furnace, sand becomes liquid, and liquid becomes precision-engineered packaging moving at impossible speed. A single mistake inside this process can destroy thousands of bottles in minutes. Temperatures climb beyond what most metals can survive. Machines move with millimeter accuracy, and molten glass behaves more like lava than a solid material. But inside a modern glass blowing factory, this controlled chaos creates something we use every day and rarely think about. Today, we go inside industrial glass manufacturing to discover how a glass bottle manufacturing line transforms raw minerals into millions of flawless containers, and why this century-old process remains one of the most advanced production systems ever built. Glass may look simple, transparent, smooth, ordinary, but behind every bottle on a supermarket shelf is one of the most demanding manufacturing environments on Earth. Modern glass production process facilities operate continuously for years at a time. Furnaces rarely shut down because cooling them can require enormous time, energy, and cost to restart. Inside these factories, temperatures exceed 1,500 degrees Celsius. Raw materials are blended with extreme precision. Massive furnaces melt tons of material every hour. Automated systems shape glowing molten glass in seconds, before robotic inspection systems reject even microscopic imperfections. This is not traditional craftsmanship. This is industrial scale precision engineering. Today we follow the entire journey, from raw materials and melting to forming, inspection, packaging, and the global business that keeps this industry alive. Before the heat comes chemistry. Every glass bottle begins as a carefully engineered recipe. The primary ingredient is silica sand. It provides the structure that gives glass its transparency and strength. But pure sand alone would require temperatures too extreme for efficient production. Factories add soda ash to reduce melting temperature and limestone to improve durability and chemical stability. Then comes one of the industry's most important efficiency secrets. Recycled glass, known as cullet, crushed recycled glass melts faster than raw minerals and dramatically reduces energy consumption. Many factories aggressively increase cullet usage because every percentage point can reduce furnace energy requirements while improving sustainability. These ingredients arrive in bulk handling systems that measure quantities with remarkable accuracy. Automated batching systems weigh thousands of kilograms at a time while maintaining strict tolerances. Because once the furnace starts, there is no room for correction. And what happens next transforms harmless minerals into something that glows brighter than steel. This is the heart of the glass blowing factory, a furnace designed to operate almost continuously. The batch enters a massive refractory-lined chamber where temperatures reach approximately 1,500 to 1,600 degrees Celsius. At this stage, something unexpected happens. Glass never behaves exactly like a normal liquid. Its viscosity constantly changes with temperature, and controlling that behavior determines whether bottles become perfectly uniform or useless waste. Inside the furnace, raw materials gradually melt and blend into a glowing river of molten glass. Air bubbles rise, impurities dissolve. Temperature zones stabilize composition. Operators monitor sensors around the clock because small thermal shifts can ripple across the entire production line. Some facilities process hundreds of tons per day, but melting alone does not create bottles. The next challenge is far more difficult: turning molten liquid into identical containers. Thousands of times every hour. This is where industrial engineering becomes mesmerizing. The molten glass exits the furnace and enters a feeder system. Special mechanisms cut precise portions known as gobs. Each glowing gob contains nearly the exact amount of material needed for one container, milliseconds matter. If timing changes, bottle dimensions change. Those gobs drop directly into the forming section where the glass making machine begins shaping. Most bottle factories use an individual section machine, commonly called an IS machine. Instead of producing one bottle at a time, multiple independent sections operate simultaneously. Inside each section, compressed air and precision molds work together. The first mold creates an initial shape called the parison. Then robotic transfer mechanisms move the partially formed glass into the blow mold. Compressed air expands the glowing material against mold walls in seconds. A finished bottle appears. What looks effortless actually involves synchronized mechanical movement, airflow control, thermal management, and high-speed automation. And despite all that technology, the bottle still isn't finished. Freshly formed glass contains internal stress. To the naked eye, it looks complete. In reality, it remains dangerously fragile. Factories send bottles into a long controlled heating tunnel called an annealing layer. Instead of cooling quickly, temperatures gradually decrease over time. Why? Because uneven cooling creates internal tension. That tension may remain invisible until a bottle cracks days, or even months, later. Inside the layer, conveyor speed and thermal profiles are continuously optimized. Thousands of bottles move together in a glowing procession, slow enough to release stress, fast enough to maintain industrial output. This hidden stage determines whether bottles survive shipping, filling, and consumer use. But factories still cannot trust appearance alone. Now comes inspection. Humans once inspected bottles by hand. Modern factories no longer rely on eyesight. Today, inspection systems use cameras, lasers, and automated sensors. Each bottle passes multiple checkpoints: wall thickness, neck dimensions, shape consistency, internal defects, surface contamination. Even tiny cracks, invisible to humans, trigger automatic rejection. Defective bottles never leave the line. Instead, they return to the recycling loop as cullet and begin the journey again. Entire production lines analyze thousands of containers every minute. Data feeds into manufacturing software that predicts failures before defects increase. The result is extraordinary consistency, because customers expect every bottle to behave exactly the same, whether holding medicine, beverages, cosmetics, or chemicals. And that expectation drives one of the world's most overlooked industries. Glass competes with plastic. It competes with metal, yet it remains essential. Why? Because glass is chemically stable. It preserves taste. It resists contamination. It supports premium branding. And unlike many materials, glass can often be recycled repeatedly without permanently degrading quality. That is why beverage companies, pharmaceutical manufacturers, food producers, and luxury brands continue investing heavily in glass packaging. Modern factories balance energy cost, sustainability goals, speed, and product performance. A single production facility can manufacture millions of bottles while operating around the clock. And behind every container is a system of chemistry, automation, thermal engineering, logistics, and business strategy. The next generation of factories may look very different. AI-assisted process optimization, predictive maintenance, digital furnace twins, energy recovery systems, higher recycled content, advanced sensors capable of identifying process drift before defects appear. Researchers continue developing ways to lower emissions while increasing output, because demand keeps growing. And the factories that master efficiency will shape the future of global manufacturing. What seems like an ordinary bottle is actually one of industry's most refined products, made from fire, controlled by machines, perfected through engineering. Inside every glass bottle is a hidden story, a story of temperatures hotter than molten metal, machines working with impossible precision, factories that rarely sleep, and engineers transforming simple minerals into products used billions of times around the world. The next time you hold a glass bottle, remember, you're holding the result of one of humanity's most remarkable manufacturing achievements. If you enjoyed going inside this glass-blowing factory and want to see more industrial documentaries exploring the world's most fascinating machines, subscribe and join the journey.